Hello, everyone. Welcome to Cloud Native Live, where we dive deep into the code behind Cloud Native. I'm Annie Talvastro, and I am a CNCF ambassador as well as I lead marketing at Vision, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer all of your questions. So, you can join us every Wednesday to watch live. So this week we have Alex here with us to talk about modernizing authorization. Very excited for this. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. So basically, please be respectful of all of your fellow participants as well as presenters. With that done, I'll hand it over to Alex to kick off today's presentation.
Great. Thanks, Eddie. Hi, everyone. Very happy to be here today speaking about authorization and Cerbos, which is an open source project that helps you decouple authorization out of your application code and into something that's a bit more manageable and scalable. So just to kick it off, make sure we're all on the same page. Today, we're going to be talking about authorization and not authentication, which are two terms that sound very similar, and we all kind of shorten them as we do as software developers to things like AuthN and AuthZ, but they are two kind of very different concepts. So authentication is about really identifying who the user is. You know, they provide some credential, you get back some sort of signed token or something, or JWT, that certifies that person is who they say they are. And then authorization is about, okay, now you know who the person is, what are they actually allowed to do inside of your system? So, you know, this being CNCF, I'm sure many of you are familiar with Kubernetes and things like RBAC inside of the Kubernetes system, and RBAC being role-based access control. That is one type of authorization. And then today we're going to be talking about application layer authorization. So once you've got an application, you have your end users. Those users might have different roles. How do you actually manage what those users can do inside of your application in a way that's kind of manageable, scalable, very cloud native in the way it's kind of deployed and managed, very Kubernetes friendly, etc. And to do this, we're going to go through a journey of actually implementing a very simple application with no permissions and kind of go through the growing pains, as it were, of implementing authorization, and then demonstrate how you can use the open source project Cerbos to do this. If you want to dive straight into Cerbos, you can find it up on GitHub, github.com/Cerbos. I think we'll put the link in the chat shortly. There we go. If you want to go dive straight in, or cerbos.dev is the website. So let's go and kick it off. I have a very simple Node Express server here, and we are going to basically go through and implement CRUD, create, read, update, delete, as well as some kind of application-specific permissions. Now, to quickly run you through how this application works, it's going to be a simple service. It's in sort of Node TypeScript. That's just because what I'm most familiar with. And because we're going to be talking about authorization and not authentication, we're doing some basic fake authentication where we're passing through a header in the request of a user's name, and then behind the scenes, we have a database of these users. So this would be usually coming from your identity provider, or your own application authentication system. Maybe it's an OAuth exchange, maybe you've got a JWT token. But each user has an ID. We have some roles. So these could be like claims inside of your token even. So in this case, we have users, we have admins, we have managers. And then each user has some attributes. In this case, we have a couple of attributes around what department they belong to and what region they belong to. And these you can imagine in like a sort of typical, maybe like SaaS type application. These would be your users in your database. In terms of what the application does, is for managing expenses. So Andy and I were just talking. We were at KubeCon a couple of weeks ago, and we have like expenses that we need to go and claim back. So we want to submit these into our system, and an expense resource inside of our system has this shape. So it has an ID. We have some attributes about it. So the owner, their ID, when it was created, who the vendor was, the amount, and the status. Is it open, approved, rejected, etc. So our basic API here has a few routes, one for getting an expense, one for seeing who approved an expense. We've got one here for actually doing the approval. So the person that maybe you got a web UI, you got a mobile app that's hitting this API for actually doing the approval. Updating, delete, typical CRUD things. So this API is up and running, and I'm using kind of Postman here just to kind of show you some requests. So we have a request coming into a particular expense. I'm going to pretend to be different users by setting a different header. And in this case, all users can do all actions because there's currently no permissions in place. But from like a business process point of view, I've actually implemented the main actions, and we can pretend this is updating a database and those kind of things behind the scenes. So now I'm the developer. I've gone and got a set of kind of requirements coming in from my product team, which in this case is also me. And we want to go and implement some roles and permissions for this. And these, permissions are going to be vary based on what role I have. And there's some conditions that must be met for a particular role to be allowed or not. And so we've got this ticket that comes in, and we've got some rules here that says, so if the person is an admin, then they should be able to do all actions. So they should be able to do those create, read, update, delete type permissions. If they're in the finance team, and the finance team is defined by someone having the role of user, and in the Department of Finance, then they should be able to view all the expenses, view who approved all the expenses, and then they should be able to do the approve action only under certain conditions. And these conditions, sorry, my camera's gone very blurry. And under these conditions is where we start coming into the difference between RBAC and ABAC. So RBAC, or roles-based access control, is the way of doing permissions where you simply check whether a user has a particular role or not. So for this admin use case, it's pretty simple. We want to go and check whether the user is an admin. If so, let them do the thing. But in reality, and as we've seen by these other rules here, that we're going to have to do some more checks. And this is where ABAC, or attribute-based access control, comes in. Because now we're not granting a permission just based on whether you have a role or not. We're actually granting permission based on whether you have a role and under certain conditions. So the approve an expense example here is kind of a good example. So you're only allowed to approve an expense if your role is user, the department you belong to is finance, and the actual expense resource that you're trying to interact with has the status of open. So here we're actually inspecting the attributes of the permissions. And most systems that you may think or you may see of being like RBAC, in reality are probably going to do more ABAC based logic, because they always want to go and inspect and make decisions based on the actual attributes of the resource you are accessing or trying to interact with to make those decisions. So if we go and take this logic, and if we go and look at create the implement this logic in kind of the classical way, or the way that most systems when you're starting small would do inside of this view command, you're going to start doing basically some if-else statements. So our first rule was, if you're an admin, you should be able to do all the actions. So for this view route, we basically want to go and write a big if statement. So if the user.roles.includes admin, then we go and do the action, and then in this case we're just returning the response. And if you don't match that case, then we actually want to go and return back to that API. I got 403 saying error, action not permitted. And here we've just done the very first check where we work out whether you're an admin. That's a pretty simple one. But now if we go and look at the next case, so the finance team, your role is user, your department is finance, then you should be able to view all the expenses. Okay, so we go if user roles dot include user, and we go and actually look at an attribute of the user. If user attribute dot department equals finance, then our logic says you should be able to view that expense, and we again return the response on that request. And then finally, for our general user role, you should view the expense if you created it. So this logic will now be quite similar. If user roles dot includes user, and we now want to check if the owner, so our user ID must be equal to the expenses attribute owner ID field. Then we go and return it to the API response, and now we've implemented just that logic required for that view command. And now you could sit here and start iterating through all those different setups, and you're going to have to go and do this for each of these. I'm going to flip over to an example rather than hard coding this all live. But you can see here we've implemented all that logic. So here's the view rule we've done with the checks on the attributes. If we go and look at the approve status, so if we go and look here, so admin can do all, the finance team can approve if it's open and they didn't create it. So we're going to look here. We said admin can do it. In this case, we're just like returning some error, returning the approve message. So for the case where you have to be the owner, we're checking if you're a user, the finance team, the status of the expense is open, and that the owner did not create it, or the person making the request did not create it, so you can't approve your own expenses. Making sure they're not equal, then we return the actual expense. If not, return sort of error. And we can go and keep evolving this and adding more logic. And this is great, getting started, something quick, off you go, implement that if-else statement, and it keeps it very simple. But now if you imagine our application is kind of evolving, and we're now moving to microservices because we've got a nice Kubernetes cluster, we've got teams building services in JavaScript, we've got teams building services in Go, we've got teams building services in Java. When the requirements change, which they undoubtedly will, anytime you have to go and implement logic, you're going to have to take essentially that business logic, so that ticket we've got, and take this and kind of map it into JavaScript and map it into Go and map it into Java and map it into XYZ other weird and wonderful language that's come along this week into your system. And this is where things start falling down, because you're now going to have to go and touch all your application code when the requirements change. And you're going to have to go and rewrite and re-implement that logic each time, re-release your application, having hopefully all the tests to pass, and kind of hope that the logic is implemented correctly because you've had to do it in multiple languages. So what's the alternative for this? And this is to move to a policy or a configuration-based workflow rather than hard coding that logic in there. And this is where Cerbos is the project that we're going to be talking about today that helps you kind of implement this business logic as configuration policy rather than code. So we're going to use this playground, play.cerbos.dev, as just a quick sort of IDE to look at how we go and implement this business logic, and then we'll look at how we then go and put this into the application. So this is a playground instance I've created. In order for us to actually get some real-time feedback based on whether the logic is implemented correctly, I've set up some example users. So these users are the same one we just saw in the application. So they have an ID, they have a role, they have some attributes, and then the resource they're trying to access. Here are some example resources of different amounts. And it's the same kind of object we saw. So we're working with the same kind of test data here. So if we go and implement a policy for our resources. So expense is our first resource. We're going to go and create this expense resource. We're going to give the name of the resource an expense. And there's some example actions in here, which we're going to go and modify. So our first rule again was admins can do all actions. So we're going to create a wildcard rule. And this is essentially all the different rules, all the different actions that users can do upon an expense resource. And we're going to say that for all actions, the effect of this should be allow. So in the case where this matches, you should be allowed. And we're going to say that for this rule says for all actions, if you match the role of admin, the effect is allow. So this policy and these roles are looking at the request or looking at the user that's making the request, in this case, user. And then for all actions, it should be allowed, and that will always match. Now, if we're going to implement that same rule that we did when we hard coded it, which was, sorry. We did say we were going to break things. So read or view. So who can go and view a resource. So going back to our business rules, we're saying to view, so admins, we've already covered because this wildcard will match it. For the finance team, you're allowed to view it if your role is a user and your department is finance, or you're allowed to view it if you created it. Now, in this case, I could go and write a lot of repeating logic for the cases of both the finance team and the owner, in this case, for a view resource. So the way I could do this is go and set up and hardcode and write that logic as an expression in here. But what I'm actually going to do is create something called a derived role. So derived roles allows us to essentially at request time, based on the inputs of who the user is and what the resource they're trying to access, set up and derive further roles for that user for the scope of that request. And the most common example for this is an owner role. So our owner role here is a derived role that says if the parent role is user, so the request coming in has a role of user, and here we're defining a condition, and here we're saying that if the request resource attribute owner ID, so we're looking essentially at every payload that comes in at request time, and we're inspecting down to the object, and we're grabbing the owner ID field. If that is equal to the ID of the person making the request, then we should grant that user essentially this extra owner permission at request time. Now, these conditions here are using CEL, Common Expression Language, which some of you might be familiar with. It's an open source Google project where you can get very expressive with your business logic. And it gives us basically the ability to write binary type logic or logic based on inputs. And the inputs in this case are the person making the request and the resource they're trying to access. Going back to our use case again, so this finance team member is actually another kind of derived role. So this person is a user, but they also have to be in the Department of Finance. So rather than typing it out, I'm just going to go and copy this over. So now we have another derived role that says you get or you're granted the finance role if you are a user and your department is finance. And that matches this data point here. So with these two derived roles of owner and finance, we can cover these cases of finance team can view all expenses and a user can view an expense if they created it, thus they are the owner. So jumping back into our policy file here, I'm going to go and import those derived roles. Common roles. And then for that view, I'm going to say you must have the owner derived role. I keep touching my trackpad with my palm, or finance. So now, hopefully you've seen as I've been typing down here on the bottom right, we've been getting some sort of live feedback as we kind of experiment and work on these different policies. So I'm currently being someone that's in like the IT department, so I have the admin role, so I do have permission to view this particular expense. If I go and look at different expenses, they're going to be allowed, and this one's owned by Sally. So if I go and look at one that's owned by someone else, so here we have the owner, Frank. If I go and look at this as someone that hasn't got the admin role, in this case, a user, in this case, Sally, she gets access denied, so cannot do the view permission or cannot do the view action upon that particular resource that's making a request. So going back to our business logic again, we have all this logic around who can approve. So we're saying it must be opened, the status must be opened, and if they mustn't have created it, and you must be in the finance team to go and do the approval. So what does that look like? I am going to go and grab a snippet again, just to save typing out, and I will talk you through it. So we have another action in here, which is approve. And we'd say for the approve action, it should be allowed if you have that derived role of finance, so you're in the finance team. And this time we have a couple of conditions in place. So as well as checking that you're in that team by looking at that department attribute, we're also now checking for these two conditions of if it's open and they didn't create it. So here we're saying there's two conditions, which both of these must match. So they didn't create it, aka the owner ID is not equal to the principal ID or the person making the request, and the status must be open. And now if we go and look at here, we're getting that feedback as we sort of go and look at different resources, who can be allowed to do what. If we go and look at someone that's in the finance team, here they're allowed to do the approve on this particular resource because it is status set to open and the owner ID is not their own ID. And so we could build up these quite complex policies of defining the authorization logic. And we get to a point where we're kind of happy with our logic and we want to actually go and actually implement this inside of our application. So let me jump back to another, here we go. I'm going to jump over to this example, which is our exact same API, but here we've actually implemented the call to Cerbos. So the way Cerbos runs is it's a container that you run alongside your application. In the Kubernetes world, we always recommend running this as like a sidecar. We have Helm charts as well for running on services, etc. But the idea is that Cerbos instance is running right alongside your application. So it's going to be a very fast lookup from your service to a Cerbos instance. That Cerbos instance has loaded into it the policies that are currently defined. And then in your application, at the point where you want to check permissions, rather than hard coding that big if-else style statement that we were coding in this previous example, we just make a call out from our application to that Cerbos instance saying, I have this principal, so this user, they have this role, they're in this department, they're in this team, open for you to define. They're trying to access this particular resource. So you pass through the resource, it's an expense, has this ID, it has this amount, it has this status, etc. And what action the user is trying to do. I'm trying to create, read, update, delete, view, approve, open-ended based on you to define inside of your policies. So that Cerbos instance is, in this case, I'm just running it locally. So we've imported the Cerbos SDK. There's SDKs for most of the language out there now. Find it all on GitHub. We connect from the service to that Cerbos instance. So in this case, I'm just talking to localhost because that's where I'm running it. If this is inside your cluster, it might be like the sidecar path, or might be like Cerbos.service.cluster local, or it depends how you want to deploy it. In this case, we're actually using gRPC as well. Again, it's very focused on performance. Authorization is in the critical path of every request, so you don't want to be going out over the internet, especially to make authorization checks. So it's designed to be all local, can be completely air-gapped. There's no external dependencies. And this Cerbos instance is you talk to it from your application. Then going down to the actual request handlers, where before we had these big if-else, we had these big if-else case switch style blocks. In the Cerbos version, we simply make a call to that Cerbos instance. So we've set up the Cerbos SDK, we've got our expense, and we pass into it the principal. So in this case, the user that made the request. The resource, so we're telling it what kind of resource, and we're passing in that full object about the resource that user is trying to access, and what action they're trying to do. In this case, view. Further down, we have like the approve action, and here we have the update, delete, etc. Then what comes back from Cerbos is for each action a very simple Boolean: is this allowed? Yes or no. So what's going on here behind the scenes? Request comes in from your end users to your service. Your service is grabbing that user's identity from your IDP or the token. It's grabbing the resource that user is trying to access from your own application database. So you might be doing a SQL query, you might be going to hit some other API, you might be calling another service. And then rather than in the application code doing that big if-else case switch style statement, we pass that context from inside your app to that Cerbos instance running right alongside it, saying I've got this principal trying to do this action on this resource, and should it be allowed or denied? Inside of Cerbos, Cerbos is taking that input of principal, resource, and action, evaluating your policies, and then simply returning back an allow and deny decision, which means you only have a single if statement now inside your request handler, which says, is this particular action allowed or not? And in this case, we're saying if it's not allowed, then we return some sort of error. If it is allowed, we then go and actually do the action and return back on the API what should happen. So at this point, we've just gone and basically replicated what we had hard-coded. And here I actually have the policies similar to the ones we had in the playground with all that business logic defined, etc. And I'm going to go and start up a Cerbos instance. So I'm going to start Cerbos. This is now running locally in my machine. Our API is now up and running. And I'm going to use Postman to go and hit it. And here we're getting kind of back decisions. And there we go. I got a action denied response for trying to get this particular expense 4, which I just know from the implementation is not one that this user, in this case Sally, is allowed to access. And if we actually go and look in the Cerbos logs, we can confirm that request has been denied Cerbos itself creates full audit logs. So every decision that the Cerbos instance makes will go and actually log that, and you can send those off into your own log collection system for kind of reporting and analysis. And it's one of the side benefits of decoupling your authorization logic out into a standalone service such as Cerbos. Engine, regardless of where your application permissions or regardless of where your architecture you're doing authorization checks come from, because they go through a Cerbos instance, it will always be logged, and you have that clean and consistent audit log of exactly what happened. So now here's when it gets kind of interesting. So because I've done the work now of decoupling my authorization logic out, I've updated my application code to call a Cerbos instance. What happens if the requirements change? So we have another ticket or another issue here from said annoying product manager, me, and we're saying we've had some client requests and we want to have a different option, a different permissioning type role inside of the system. And the business logic for this particular example is we no longer want to have a single finance kind of role. We want to break it between finance team and finance manager. And the business logic says that if you're a regular finance team member, you can only approve expenses up to $50,000. If it's over that, you must be a finance team manager. And if you imagine we had this all hard coded before, we'd have to go and update all that if else case switch style logic in not just this service, but every other service that relies on the kind of those permissions to handle this. And that logic is going to be spread because across potentially many request handlers across many services and many numbers of languages. Because we've done this decoupling, there's now one place and one source of truth for what our permission logic is. So let's now actually go and implement this finance manager role. And we're going to do this without touching our application code. We're purely going to be touching our policies. So first thing first, we want to work out who is a finance manager. So in our IDP, in our user database, we now have a new user role, which is manager. So if you're using some self-hosted authentication system, you're using a managed service for your identities or directory, you imagine you might have some attributes about your users like before. We're now adding this manager role to our users in our kind of identity provider. And that's passed through to the application in the token or wherever you get your credentials back. So Derek here is now our manager in the finance team, and thus he should be able to do the approvals of $50,000 or more, whilst Frank here is just a regular user in the finance team, so shouldn't be able to approve over $50,000. So let's go and look at our policies. As before, we're actually going to go and create a derived role here just to kind of simplify some of the logic. So we now have that finance derived role, which we had earlier, which just checks if you're a user and in the finance team, whilst our finance manager derived role here is a parent role of manager. So that's coming through from your IDP. So we're checking whether that exists and your department is finance. So now we're creating this derived role at request time for every request that comes in. And in our resource policy, we want to go and look at the approval logic. So here we have our approval logic as before. But now for our regular finance team members, we have a new condition, which says that it must be less than 50,000. The amount field, so the amount attribute of the expense that this user is trying to approve, must be less than $50,000 in this case. And if you try and approve it and you're just a regular finance user and it's over that amount, this will fail and you'll get a permission denied, as you kind of expect based on our business rule. So that now means we need to go and create another case, another rule for this. So we're going to say also for the approve action, we want to allow this if you have the derived role, which we just created, of finance manager. And in this case, we're going to have essentially the same conditions as before, but we're going to take away that 50,000 sort of limit. So just to recap, we've added a new derived role of finance manager, where the user has the parent role of manager and they're in the finance team. We've added a new rule here that says the action should be approved. Excuse my typo. The action here will be allowed. The approve action will be allowed if you have that finance manager derived role, regardless of the amount. And we've added the condition here, which says to do the approve action and in the regular finance team, the amount must be less than 50,000. So because we're big fans of the GitOps style workflow, we're here at Cerbos, and being kind of a player in the cloud native ecosystem, everyone loves GitOps. We can actually go and write full unit tests against it, which I won't dive into here, but I'll point you to the documentation for this. But we've written some examples of conditions that have been met, and example inputs of resource and actions to check that your policies pass. I can go and run these tests locally. So we have CLI tooling. So look, it's telling me I've got a typo in my policy, which I do somewhere. There we go, derived roles. Run this test again. Still got another role. Bear with me. Oh, that should be a list, that's why. There we go. There we go, and all my tests are passed. Beauty of tooling. I'm now actually going to push this change up. So update to add manager role. So that is now all going up. So depending how you deploy your Cerbos instances, you configure where it gets its policies from. If you're following the hardcore kind of GitOps style workflow, imagine you have your pull request, you have a whole CI pipeline running in there, and then your Cerbos instances themselves are going to pull down that change from your Git repo on some sort of basis. For simplicity, I'm using the Cerbos cloud version here, which is doing the builds for me. We can see here that a new build was generated 18 seconds ago. We can go and see how many tests are passed, the status of all the tests, etc. Kind of the typical things you would get in a CI pipeline. And that Cerbos instance that I am running is pulling down that update and is now serving decisions based upon these new policies. Just to show you how this kind of works, I'm just going to create an empty commit just to show you kind of the workflow. So that's pushed up, Cerbos Cloud goes and builds it, and the CI pipeline is running, and in this case, that update gets pulled down straight away based on the new commit, because all the tests have passed, because the policies are valid and loaded into memory, and the Cerbos instance or instances that you're running, because you can run many of these as, say, sidecars, will get updated to that latest logic. And so if we go back to our application, and all things being right, we have our new user. If we go and get expense number 4, expense number 3, as Frank, this is an expense that's at 80,000. Frank here is our regular finance team user. So if we go and see whether he can go and do the approve action on it, action not permitted. If I swap to a user that we set on our database as the finance director, can he do the approve action? He can. So what we just demonstrated is the business logic for authorization has been updated via a change in policy and pulled down to the Cerbos instances without me having to touch the application code. So in my application code, going back, I have not changed this lookup. Cerbos is receiving the principle, the resource, and action from the application. Cerbos is then evaluating whether a permission should be allowed or not based on the current policies that are live, and returning back as the same allow or deny decision back to my application code. And I don't need to make any changes here in terms of how that's handled. It's simply saying, is the approve action allowed? If yes, we then go and do it. If not, we return some sort of error. And thus, we've now decoupled that authorization logic out. It's now in policy. We can have a full GitOps style workflow where we have a CI pipeline that runs those tests, as you kind of saw. Changes can be reviewed, approved, tested, and then deployed out. And now you can update, add roles, change requirements for authorization, all via policy rather than hard coding it. And so every service that now checks permissions via Cerbos gets that update without you having to redeploy, retest, recode, all that logic. So just to wrap up and point you to a few resources, if this says set any light bulbs off or answers maybe a pain you've had in the past where you kept getting requirements changing for authorization, do go and check us, the Cerbos project out, github.com/Cerbos. Play.cerbos.dev is the playground that we've been showing you today. And then Cerbos.dev is the website, which is a lot more about this. Everything's open source, Apache 2 license. You're free to go and use it as you wish. We've got users both big and small now using this project, and love to kind of chat more and answer any questions you may have. You can book a session through our website if you want to chat with us, and hopefully see you around.
Perfect. So time for the Q&A then. So now is the perfect time to send in your questions. If you have any, obviously you can chat with Alex, as he kind of said there, in the future as well, via all the different means that he said there. But if you have any questions now, you can type them into the chat and we'll get them answered. While we wait for those questions to hopefully roll in, if anyone has any, I would have a question.
Sure.
So we spoke here about like the modern take on authorization and whatnot, and covered a lot of different topics. But what would you say are the next steps for Cerbos? Is there something that you can kind of sneak peek from the product roadmap going further, or so forth?
Yeah, absolutely. So Cerbos, we're really focusing on the developer experience. So I mentioned quite a few times that the tooling, the CI sort of pipeline you can set up with Cerbos. We're constantly iterating and evolving on that to make sure that you have not only a kind of smooth pipeline for getting policy changes out, but even upfront in terms of making sure that the IDE and the workflow for actually writing policies in the first place is slick. So recently, for example, we published the schemas for those policy files you've seen. So you can light up your IDE with IntelliSense and autocomplete and those kind of things. We have the Cerbos CLI tool, which allows you to run those tests and run a server locally, etc. And then if you don't want to manage a pipeline yourself, we have the Cerbos Cloud, which we announced at KubeCon actually, which is a managed pipeline that deploys and manages and tests and deploys policy changes in a synchronized manner across all your instances, built on top of the open source engine.
Great. And then we have a question from Sharon. They ask how to integrate servers with API gateway.
Great question. We get asked this quite a lot because it's a hot topic right now, particularly also the service mesh side of things as well. So where Cerbos sits is in the application layer. Your top level kind of API gateway or type access is possible to write kind of an extension and have your gateway call to Cerbos based on purely the request parameters. So in that case, the only context you'll have about the user and the resource is maybe the authentication token, a JWT, and what route they're trying to request. So you could pass through the URL, the headers, those kind of things, and make policy decisions upon that. And that totally works, and there's users out there doing that today. Where we generally see Cerbos implemented, and the kind of the place where we see Cerbos implemented the most, and kind of how we designed it, is now actually inside the application. So after the gateway, someone's actually now in the context of, say, a request handler, where you know much more about the user, because you can go and fetch state from your own user database. We know all the information about the actual resource they're trying to access. So you can go and fetch that from your own database. You have full access to all the attributes about that particular resource. And this is where that RBAC, ABAC kind of story comes in. Because in most cases, the permissioning, as we saw the examples here, is actually more about the specific attributes. If we take the example of the action should only be allowed if the amount is less than $50,000, if all you have is the URL, you're not going to be able to kind of derive that. So inside of your application level kind of permissions and request handler is when you have access to all that state. And that's generally where you would implement Cerbos to do those permission checks, because you can pass through all the state from the request plus your own kind of application state to Cerbos and use that as inputs to make decisions upon inside of your policies.
Perfect. Now, if anyone has any more questions, send them in. And I would have now a question from a bit of a different direction, kind of. I love talking about people with this sort of, what do you say, since we've now been talking about authorization and RBAC and whatnot, do you have any guesstimation or any hopes for how this field will evolve in the future? What would you like to see coming up?
Yeah, great. So when I kind of look at this space and kind of where Cerbos sits, we're in an environment that isn't in isolation. We have the authentication piece, and we're now in a world where there's really kind of good standards around authentication. You got OAuth2, you've got JWTs as a kind of token exchange. That's kind of a very kind of standardized place. Authorization today is not quite there. It's still quite open for how you go and implement it. And this whole concept of decoupling is actually still relatively new. So really, the big focus that we've been with this project for the last 18 months, 2 years since we open sourced it, is like, how can we get everyone comfortable with this idea of decoupling the authorization logic out of the application into a way that's far more manageable and scalable and easier to kind of reason with, because it's not deeply coupled to your application code. And that's kind of a space that, there's many different ways of doing it. There's lots of interesting approaches, the different access models. And we think Cerbos is a good fit for kind of your typical SaaS B2B applications or internal services, and that's kind of the use case we built upon. But there's also a third bit, which is the audit story, or the accounting story. So authentication, authorization, and accounting. And generally what that looks like is the audit logs. So now you've authenticated someone, you've authorized them. How can you actually keep track of what they've done and what they're doing? And that's why the audit kind of story was built into Cerbos on day one, is really capturing that output at this time, this principal thread, this section, the resource. And I think there's a whole interesting ecosystem and future around what do we do those audit logs from an application level to actually make much more informed decisions, or around how we should reason our policies, or maybe certain users are over or under permission and those kind of things. And then I think there's great opportunity and great space there to really innovate and build much more interesting projects and that kind of help with that accounting and audit story.
Sounds good. I love the answer. And then we had Shubhma asking about the recording, and don't worry, the recording will be immediately essentially available in, for example, CNCF YouTube, so you can check that out from there. I think it's under the live streams tab there. So CNCF YouTube is the place to go for that. And then Alexander also had a question. Is it possible to do a partial check as OPA? You ask Cerbos service which resources the user has access to, and it returns a list, and so the service consumes this list.
Yeah, great question. I think this is the first sort of stumbling block people run into when they want to decouple the authorization logic. Because if you have a database or records of millions of records, and you want to just show, say, on a listing page, those ones that a user would have access to, you're not going to go and fetch all million records, send them to an authorization service just for it to return maybe the one that record that user might have access to. Highly inefficient. So Cerbos, we have something called a query plan, where you say to Cerbos, I got this principal trying to do this action on this type of resource. And what Cerbos gives you back, and I'll give you a live example here, is a query plan. So a query plan from Cerbos is a abstract syntax tree, an AST of conditions, which are computed live based on the policies that are currently implemented. And this condition tree can then be mapped into something like a SQL where clause. It can be mapped into a Mongo filter. It can be mapped into some filter on an API call somewhere, because it's agnostic to any particular data storage technology. My background's from like high throughput, low latency systems where we store data in very specific set databases for very specific reasons, mainly for brand performance. So our data wasn't all in one big Postgres database. It was split between HBase and Redis and some SQL servers. So we haven't coupled the Cerbos query plan to any particular storage technology. It is abstract and a very predictable and it's an abstract syntax tree of conditions, basically, which is dynamic based on who makes the request. And you'll get a different response back. And this is built into our playground, where you get a different set of conditions. So for this, if this person tried to view the resource, the expense resource kind, here are the conditions that I would then convert into a SQL query. And we have plugins for like Prisma, SQL Alchemy, as kind of the two common ORMs. But we've had users that map this into all sorts of weird and wonderful storage filters. And this simply says that these particular fields must be of this particular value. And Cerbos behind the scenes is doing as much optimization as it can to return the smallest set of conditions that you apply to your data fetching layer, just to return the instances of that resource that user would be able to do that particular action to.
Great. And then I think there's no more new questions at the moment, but final call, if someone's typing away, send the questions in. So while we see if anyone sends anything in, Alex, do you have any final words or anything that you want to kind of mention at this point?
If you found this interesting, or you feel like this is something that is a pain you've had to go and deal with in the past, please go and check us out. Cerbos.dev is the website. GitHub.com/Cerbos as well for the Git repo. As I said, everything's open source. Go and use it. We have users ranging from small startups to multinational enterprise companies at this point. We're here to help. We have a Slack community. If you want to jump in there, we can ask questions. We're a globally distributed team, so there's always someone online. And yeah, feel free to reach out to me on Twitter or email or through the Slack community. And I'm always happy to chat about authorization and how we can make people's lives easier.
Perfect. I think making people's life easier is a great note to end today on. And so thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a session about modernizing authorization. We also really love the questions and the interaction from the audience. Always happy to see that. And in the coming weeks, we have more great sessions coming up. And thank you for joining us today, and see you all next time.